right, we're gonna check this out. We're gonna see how far we need to go. All right, here we go. So we've got this thing called the law of gravity, which basically means that whatever goes up must come down. No matter what it is, balloon, even if it goes up, it's gonna come down. See this plate? If it goes up,
No.
well, maybe we won't do the plate, but y'all get the point. We're gonna build some ring gliders and we're gonna defy the laws of gravity. All you need for this experiment is a half sheet of paper and some tape. So the very first thing you want to do is you want to make sure you have half sheets of paper. So as you can see, we are folding the paper, folding it, and then we're going to, once we get a crease in it on the ends, we will split it into 2 sheets because we want half a sheet. I'm using my ruler to flatten out the crease just to make sure that my creases are flat. And now we are just ripping the paper in half so we can have our half sheet. And again, your half sheet may already be provided, but if not, this is just a simple way that you can make sure you have half. Next, you want to fold your sheet about 1/3 of the way. So if you're able to divide the sheet of paper into 3 parts, you want to fold it 1/3 of the way. That's a fraction for you. And again, I'm using my ruler just to make sure it's flat, get all the creases out, flatten my creases. Once I do that, I'm going to fold it a second time. And you want to make sure that it is as you can see, I'm flattening it again with my ruler. Keep my folds crisp. And then we'll fold it a 3rd time. And again, we're gonna flatten it out. Gotta keep those folds tight. All right, once you do that, now this is a little trick I picked up because you're gonna have to roll up your sheet. So I'm using the edge of my table to kind of loosen it up so it'll be easier to roll. And you'll see what I mean in just a moment. So now we gotta roll it into a ring, and if you look closely, I'm taking one end and I am just sliding it up under the other end so that it forms a circle. And at this point, you may want to grab you some tape because you will need some tape. All right, again, so we're gonna put one end and we're gonna place it under the flap on the other end. Gonna get it in place, and then we're gonna apply some tape to hold it in place. right, once you have your tape on, and as you can see, I put it on the top end and the bottom end just to kind of even it out. And that's pretty much it. Now, once you put your tape on, you can kind of straighten it out, make sure everything is as even as it'll get. And at this point, you should be ready to test it out. In order to fly, an object needs to overcome the force of gravity. The Earth's gravity pulls things down, so these ring gliders have to take advantage of other forces that temporarily override gravity's pull. Lift is a force created by air flowing over the curved surface of the ring, and thrust is the force given to the glider when you throw it. Both lift and thrust help keep the ring glider in the air. Drag is a resistance met when the ring glider moves through the air. It slows forward motion, which reduces the lift. The ring glider is a very compact design, which helps decrease the drag. So because lift and thrust are stronger than the drag and gravity, the glider will fly. North Carolina connection. So shout out to our great state of North Carolina. We are known as the first in-flight state because of the Wright brothers, who flew the first sustained, powered, heavier-than-air human flight in Kill Devil Hills in 1903. The Wright brothers' achievement began aviation as we know it today. People have always been fascinated with the idea of flying. While ring gliders like these wouldn't work for carrying people, they help demonstrate that there is a huge variety of shapes that will fly.